Welcome back, and on this part of the review we're going to start with problem 13 for the given polynomial function, determine its properties, and sketch a complete graph. Okay, here's the problem. So first of all, we know that this is going to look similar to x to the third power because of the powers here. We have x squared and x multiplied together, so it's going to be similar to x to the third. Let's start with the zeros of the function. Zeros are going to be x minus 2 equals 0. So that's going to be at x equals 2, and it's going to have multiplicity 2. So that means it's just going to touch at that point. Okay, and then the other 0 is x plus 4 equals 0. So that's going to happen at x equals negative 4. So at negative 4, we have a 0, and at positive 2, we have a 0. Now this is going to be an increasing function overall because the x to the third power, if we were to multiply this out, the x to the third is positive here because we have a positive here and a positive here, and when we multiply, so this function is going to be increasing and then go back down. Actually, it's going to increase, then go back down, touch this one, and then go back up. So that's what it should look like overall. Okay, because its end behavior as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, f of x goes to negative infinity. All right, let's try to find out what the 0 is, or what the y-intercept is here. So the y-intercept is when we put 0 in for x, okay? So we have 0 minus 2 squared times 0 plus 4. So basically it's squared here, and then that's going to be 4 times 4, which is 16. So it's going to cross at 16 on the y-axis. So if we set everything by 2 here, so this would be 4 right there. 8, 2, 4, 6, 8, 10, 12, 14, 16. It would cross right here at 16. We use 2 for every mark on the y-axis. Alright, now what we would need to do here is find some other things like the zeros. We need to plug in a few points to figure out exactly where it comes through this. So we would need to make a chart of values. We're doing this by hand. Let's try, we know what it is at 2. We know what it is at, okay, so let's go halfway in between here. We're going to go between these 2 points. We're going to go at negative 2. Figure out what that is, and we're going to go at 4. Figure out what that is. And then we're going to go also at negative, this is negative 4, so let's go at negative 6. So a few extra points to see what it looks like. I know that it goes up through here, comes back down, and bounces off that curve and then goes back up. So let's just try a few points in the equation. Negative 2, that's going to be negative 4 squared, which is 16. Negative 2 minus 2 is negative 4. 16, and then 16 times 2, so that's going to be 32 here. Right, and then 4 is going to be 2 squared, 2 minus 2, that's 4, 2 squared, that's 4. 4 times 8 is 32 also. And negative 6 in there is going to be negative 2, or so negative 8. So negative 64 times 2, so negative 128. So some very big numbers here. So looking at the graph here, we're going to have to, I mean, it's going to go up to like negative, it's going to go up to 32 up here on both of these graphs. So it's going to come up very high and then back down and then touches here and then goes back up very high. Okay. So some of the points that we have here are 4 and 32 and negative 2 and 32. Now let's look at the graphing calculator and see what it says to us. Now is this, let's just double check here. It doesn't say that we can't use that. So let's try that out. We need a new one. Okay, we're going to put in function x minus 2 squared and x plus 4. We know that we're going to need to at least go up to 32 on the graph, so we're going to set the window so that it's at negative 40. We'll go negative 50 and positive 50. Go by 5s. So it looks like that. Now let's see what the maximum here is, because I turned that graph right at negative 2. It looks like the maximum is at negative 2, but let's just double check. Okay, let's just double check the maximum. I think it's going to be at negative 2, 32. And that's what it says. Negative, it's really close to negative 2. Negative 2, 32 is the maximum. So we did graph this correctly where we put the negative 32 there. Alright, so that's what we would do on this to get the accurate picture. Alright, let's move on to the next problem, which is 14. We're asking to do synthetic division, I believe. Long division. Okay, long division in this problem. So long division, x minus 1 divided into 3x to the 4th. Now there aren't any x cubes, so I'm going to leave a space for the x cubes. 8x squared minus 7x minus 4. So I'm leaving a little cubic space there for no x cubes. Alright, we divide x into 3x to the 4th. 3x to the 4th divided by x, that's going to be 3x to the 3rd. So you multiply here by both of these, so you get 3x to the 4th minus 3x to the 3rd. We're going to subtract that. That changes this sign to positive, and it'd be 3x to the 3rd. We bring down the next one, 8x squared. We then divide this into this one. That's going to be another 3x squared. So we multiply 3x squared times x, so we get 3x to the 3rd. And 3x squared times negative 1 is negative 3x squared. We subtract. So that would be 11x to the 2nd. We bring down to minus 7x. We would then divide x into 11x to the 2nd. So we had 3x to the 3rd divided by x. Okay, and then we have 11x squared divided by x. So that's 11x. So we multiply here, so that's 11x squared minus 11x. We subtract, changes to positive. So it'd be positive 11 minus 7, that's going to be 4x. Bring the minus 4 down, and we have 4x divided into by x, that's going to be 4. So we're going to put a plus 4 here. And that gives us 4x minus 4 when we divide, so we have no remainder. So this is our answer for that division problem right here. 3x to the third plus 3x squared plus 11x plus 4. Alright, now in this one, if we divide that pair, let's use a different color. So x squared plus 2 divided into 5x cubed plus 6x squared plus 8. Now I didn't leave any spaces here. Let's try let's see if I can fit it in here. We divide these two terms, the x squared or the 5x cubed by x squared, we get 5x. So we're going to put 5x here. We're going to multiply this times that and get 5x cubed. 5x times 2 is 10x. We don't have a space for that. I'm going to put it over here because there isn't any x's. It'll go right over here in between that. We're going to subtract. This goes away. This one comes down, 6x squared. And then we subtract, so it'd be minus 10x. And then plus 8. That's what's left over. Now x squared goes into 6x squared 6 times. So we're going to put a plus 6 there. So 6x squared, and then 6 times 2 is 12. We subtract that. So that goes away. We still have a minus 10x. And a minus 12 from 8, it would be negative 4. So our answer to this would be x, or 5x, plus 6 with this as a remainder. So that's going to be negative 10x minus 4 over x squared plus 2. So this is how it would be written. We could also factor out this negative and make it minus here and make these both plus. So that would be dividing those two things by long division. Alright, let's look at the next problem. Next problem says without a calculator, graph transformation. So we're going to do this without a calculator. So I think we're going to wait and do that on the next, we'll do that on the next video when I have more time. So we're going to start at 15 on the next video. So that's where we'll start.